Hello, welcome. This is a lesson on similar triangles and how they are proportional to each other. We could say that two figures are similar if and only if there's a dilation that maps one figure onto the other. In the new figure, corresponding angles are congruent and corresponding sides are proportional to the original figure. You can denote that two figures are similar by using the symbol in this little squiggly line symbol. For example, triangle ABC is similar to triangle DEF. That's a similarity statement where the two triangles are named in order of their corresponding parts. So angle A corresponds to angle D, and so on. In the examples below, state if the triangles in each pair are similar. If so, state how you know they are similar and create a similarity statement. So you might remember from your studies how to prove congruent triangles. Well, to prove triangles are congruent, are similar, you only need to show that two corresponding pairs of their angles are congruent. The third would then be congruent by default, but you only need to show that two angles are congruent. And so if I look at example one, I can see that angle A and angle C are congruent. They're marked with um, that single tick mark on the arc. So those two are congruent. But I also know that angle BEA and angle CED are also congruent because they're vertical angles. And there I have two pairs of congruent angles. And so we can say, yes, they are similar. And so our similarity statement, you just choose a vertex to start with. We'll go ahead and start with A. So we'll go to A and then over to B and then to E. And I'd say that this is similar to, and I have to see which angles are congruent, are corresponding. So I know A is congruent to C. I've marked those already. So A, and then I would say C. And then I went to B that isn't marked. So I'm going to go over here to D that's not marked. That's going to be my next one here, D. And then finally back to E. And so that's our similarity statement. All right. For example 2, another way of knowing if triangles are similar, is if their sides are proportional. And so I'm going to compare the short side. I'm going to go over here and I'm going to say, okay, here's this small triangle and large triangle. I'm going to say the small side and then let's say let's go say the large side. So of the small triangle, the small side is 5. And I'm going to compare that to the large side, which is 12. And then I'm going to ask myself, is this equal to the small side of the large triangle, which is 10, compared to the large side of the large triangle, which is 24? And to know if those are equal, we have a number of different ways we can do this. We can see if we can simplify them. Or we can do where we just plug them into a calculator. I'd say 5/12. 5 divided by 12, get the decimal, and compare that to 10/24. 10 divided by 24s, and it gives me the same decimal. You can also simplify it to see if it gets to the same simplified fraction, but those are definitely equal. Let's compare the middle side. Let's go small side. Let's do the same thing here. The small triangle, big triangle. Let's say the small side with the medium side. and the small side is 5, the medium side is 10. On the larger triangle, the small side is 10, and the medium side is 24. Not 24, 20. And both 5/10 and 10/20 simplify to 1/2. So sure enough, they are also, so we can say, again, yes, these are similar. And they're not labeled. So in terms of a similarity statement, we'd need to label them. Let's go ahead and call this one A, B, C, and we'll go here D, E, F, and we'll label them. That way we can create a similarity statement. We say this is triangle A, B, C, and it's similar to triangle D, E, F. All right, let's look at example 3 here. Another way that you can show congruency, or sorry, similarity, is through side angle side. If you can show that the two sides are proportional and that the included angle is congruent, then those would be similar. So we can see that these two angles are congruent. They are marked as being such. Then we just need to see if I can say 12 is to 36, this side is to 36, as 15 is to 45, and I don't know that they're equal, so I'm going to put a little question mark there, see if they're equal. Well, I know that I can divide 12 by 12 and get 1, and 36 divided by 12 I can get 3, so that one is equal to 1/3. 15 goes into 15 once, and 15 goes into 45 3 times, and so they both simplify to 1/3. So their sides are proportional, and the angle in between them is congruent. So by side angle side, they are similar. So once again, we can say yes, they are similar. Let's mix this up a little bit. This time I'm going to label this one as A, B, C, and we'll call this one X, Y, Z. Remember to use capital letters when you're labeling vertices. And so it's a triangle ABC is similar to triangle XYZ. All right, we move on to the next example. Here it says that the triangles are similar. Solve for X, then write a similarity statement. If they are similar, then their sides are proportional. So I can compare the small side here, BC, 3, to the large side, 6. And then I can set that equal to either one. Since this is an isosceles triangle, both are of the other two sides are congruent. I can just say that's equal to the small triangle, 4 over x plus 2. And then one way to deal with this is just through cross products, because in a true proportion, the cross products are equal. We'd say the product of the means is equal to the product of the extremes. And so I can say 3 times x plus 2 is equal to 6 times 4. Now, you don't have to do it that way. You can say, I could go over here and say 3 is to 6 is 4 is to x plus 2. And I would get rid of the x plus 2 from the denominator by multiplying both sides by x plus 2. And that cancels the x plus 2 on the right. And then I get rid of that 6 by multiplying both sides by 6, but times 6 here and times 6 here. And that cancels the 6 on the left. So what you get as a result is 3 times x plus 2 is equal to 4 times 6, or 6 times 4. And that's the same thing that we got just by taking the cross product. So it is a little easier to just remember that in a true proportion, the cross products are equal to each other. So we use the distributive property here and write this as 3x plus 6 is equal to, and 6 times 4 is 24. And I subtract 6 from both sides, and 3x then is equal to 18. I divide by 3, and x equals 6. So there we've solved for x. X equals 6. And then it says to write a similarity statement. And so we can go back here to write a similarity statement, and we can write A to B to C, triangle A, B, C is similar. We started with the point of the vertex in between the two equal sides. So over here, we're going to do the same thing. D is the vertex in between the two equal sides. And so this would be triangle D. Then we went to B. And so here we're going to go to E, D to E, and then F. So this is our triangle similarity statement, and this is the value for X. All right, in example 5, it says find a pair of similar triangles in the diagram, explain why the triangles are similar, and write a similarity statement. Okay, so one triangle would be this A, P, Q. You can just kind of separate that out. It's that top part of this little pyramid thing. And then the other triangle would be A, and then B, C, the larger triangle. And we know that angle A is congruent to itself. It's called the reflexive property. Anything is congruent to itself. And then we can say angle PQA is congruent to angle BCA, because when you have parallel lines, these two angles that I've marked are corresponding angles, and corresponding angles for parallel lines are congruent. So we have shown that there are two angle A from the one triangle is congruent to itself, angle A, and angle PQA is congruent to angle BCA because of the corresponding angles of parallel lines. I've got two pairs of triangles, then we can say, yes, this is similar. And we can write our similarity statement that triangle APQ is similar to triangle ABC. All right, in example 6, it says find a pair of similar triangles in the diagram. Explain why the triangles are similar. Write a similarity statement. Now, once again, we've got the small triangle here, and we've got the large triangle there. And so those are the two triangles we're dealing with. We know that they have two angles that are equal right here with the right angles. And we can see well, there's an easier way to do this, and it's just like the one before. This angle here is congruent to itself, and that's this angle in the smaller triangle, and it's also the same angle for the larger triangle. And so right there we've got angle, angle. There's all you need to show that these are parallel sides. I'm not parallel sides, similar triangles. So we're missing, oh no, we've got a vertex. This vertex here is G, and then the small here is M, and then this is K. And so we can go triangle G, M, K is similar to triangle G, F, H. And there would be your similarity statement. However, it asks us to find the length of segment GH. Now, GH is this one right here, and we don't know what that is, so we'll call that X. And I know that this side length here is 7. That's this one right here. And the large one is 20. And so I can say 7 compares to 20. Those are corresponding side lengths. As 11 compares to X. The long leg, remember the legs are the ones that make up the right angle. This long leg here is compared to this long leg here of the larger triangle. And so we've already marked that one as X. And so we can say 11 is to X. And then, as I said before, we can just do cross products. So this 7 times X is equal to 11 times 20. And then we can divide by 7 to get rid of the 7. And then we've just got 11, X is equal to 11 times 20 divided by 7. We can plug that into our calculator. 11 times, what did I say, 20 divide by, oops, not times, divide by 7, and that gives us 31.4. So X then is approximately equal to 31.4. All right. The triangle proportionality theorem. If a line parallel to a side of a triangle intersects the other two sides, it divides the triangle proportionally. So in this triangle, if segment CD is parallel to segment BE, then, or line BE, then you can say that AB is to BC as AE is to DE. All right. So in the triangle at the right, find US. All right. Let's go ahead and mark US as being our X. And because these two sides are parallel, then the triangle proportionality theorem applies. And I can say 10 is to 4 as 14 is to X. And then I use the cross products. 10 times X equals 4 times 14. Divide both sides by 10. X then is equal to, or approximately equal to, let's see, 4 times 14. 4 times 14 divide by 10. And that gives us 5.6. So X is equal to 5.6. In the triangle at the right, find JG. JG, once again, we're going to write that as X. So 20 is to 30 as 11 is to x. 20x is equal to 11 times 30. Divide by 20. That cancels the 20s, which gives us that x is equal to, or perhaps approximately equal to, 11 times 30 divided by 20. 11 times 30 divided by 20. And that gives us 16.5. All right, in example 9, solve for x. They've given us the triangle LMN is similar to triangle LVW. LMN is similar to LVW. Let's see here, LM. M corresponds to V, so I'm going to write that these are similar, M and V, and N corresponds to W. And then obviously L corresponds to itself. So the corresponding parts that are proportional, I'd say 18 corresponds to 42. 18 to 42 would be equal to 24 compared with 11x plus 1. Cross products gives us that 18 times 11x plus 1 is equal to 24 times 42. And I'm going to use my calculator here because I don't, right off the top of my head, remember what 11 times 18 is. 11 times 18 is 198. So this is 198x plus 18, and that's equal to, and then 24 times 42. 24 times 42. 24 times 42 is 1008. Subtract 18 from both sides. So 1008 minus 18 is 990. 198x then is equal to 990. Divide by 198. Divide by 198. And x then is equal to 5. All right, solve for x in this triangle. We've got triangles GFE is similar to triangle TUV. So I'm going to compare TU with GF. TU is 15 compared with GF, which is 40. And that should be equal, because they are similar triangles, to x plus 4. So that x plus 4 has got to go on top, because I started with 15. I've got to start with x plus 4. Start with this, I'll call it the smaller triangle. And that compares to, that's x plus 4 is VU. VU, or UV, compares with FE. And FE is 32. So this goes here to 32. And cross products would give us that 40 times x plus 4 is equal to 15 times 32. And this would give us 40x plus 160 is equal to, and 15 times 32. 15 times 32 gives us 480. So subtract 160 from both sides. 40x on the left is equal to 320. And then divide by 40. And if I take 320 divide by 40, 320, try that again, divide by 40 is 8. So x then is equal to 8. And that's how this works. Good luck with your homework. Practice, practice, practice.